Hello, stats students. Welcome to the last section of Chapter 7. We are going to be making confidence intervals for variances and standard deviations. So in 7.4a, we found our critical values, our chi-square values, because remember, variances and standard deviations have a positively skewed graph. We can't use our z values or our t values. So here's our formula. It looks a bit intimidating, but don't worry. Remember, we can break this down. So if we're talking about variance, remember how variance is a tool to get to standard deviations. So our variance formula, remember, is sigma squared. So I've got my sigma squared in the middle. We know that our interval will fall somewhere between these two values. So we'll take our degree of freedom times our standard deviation squared, that's a sample, over our chi-square right value. On the right-hand side, our degree of freedom times our variance over our chi-square left. Please notice that the chi-square right is on the left side of the interval. The chi-square left is on the right side of the interval. Don't mess those up because it will really screw up your answer. So once we've got that, it's not hard, right? We have to have our critical values to put in those denominators. So then obviously we know that if sigma squared is that formula, in order to get to our standard deviation, we square root. So it's the same formula, just underneath the radical on each side. So we know that our population variance is somewhere between those values. Our population standard deviation is somewhere between those square rooted values. Degree of freedom, or n minus 1, whatever you want to put in there for your formula. Rounding rules, I have two things to say here. First of all, round off to one more decimal place than your original data. However, when you go from your variance to your standard deviation, do not round your variance and then use that value for standard deviation. Square root unrounded values to get from variance to standard deviation. Super important. You'll get different answers because you're using rounded values, right? We want to try to be as precise as possible. That's why we have that answer button on our calculators. Use that to your advantage. So let's do a example. I think you're going to get this because you know how to make confidence intervals. So remember, we're saying that our variance or our standard deviation is somewhere in this value. We've used our confidence level to find our chi-square values, so we can feel 95% confident that our standard deviation is somewhere between these two values. If we're 90% confident, they have a 10% room for not being in that interval. I know I said this, but I want you to write down, please do not mix up your chi-square right and left values. You get the wrong answer. Your interval won't make sense if you're looking at it. So let's talk about an interval. So nicotine content is of 20 cigarettes. By the way, smoking is gross. Has a standard deviation of 1.6 milligrams. Estimate the population variance and standard deviation with a 95% confidence level. Notice the wording's a little bit different. We're estimating the population variance and standard deviation. We're making an interval in which it could be contained. So let's jot down a few things. What do we need to know? We need to know our degree of freedom, right? Or our n if you prefer. So if our n is 20, our degree of freedom has to be 19. We probably need to know our s, that's in our formula. And we're going to need to know our critical values, our chi-square left and our chi-square right. That's why we spent the time in 7.4a looking those up so that you can find those. So let's see, if we're going to look up our well, we can fill in our standard deviation, right? 1.6, that's shouting at you. Let's see, if our alpha is equal to 5% or 0.05, that means our alpha over 2 is equal to 0.025. So I'm going to use that 0.025 when I look up my right. Subtract that from 1, so I'm going to look up a 0.975 when I find my chi-square left. Using degrees of freedom of 19, it looks to me like, let me find this, 8.907 for my left, and a 32.852 for my chi-square right. Let me know if I'm wrong on those numbers, but it looks like those guys are good. So I'm going to set up my variance. So sigma squared is in between these, and then we can go to our sigma, right? I don't feel like we need to write down these both times. So let's get your information in our variance formula. So what's it going to be? It's going to be our degree of freedom, 19 times our s squared. It's our variance, right, is in the formula. Formula has variance. We know that variance is standard deviation squared. So I know I'm going to have a 1.6 squared here. If I give you the variance, you're not squaring because it already was there. That's got to be over our chi-square right because the right is on the left side of the formula. You're welcome for that, 32.852. So then on our other side of our interval, we do the same thing. We've got our degree of freedom times our variance, which is standard deviation squared, all over our chi-square left, 8.907. Your smaller chi-square value goes on the right. When you divide by a smaller number, you get a larger answer, which makes sense in an interval, right? So I'm going to just jot down that my sigma squared, my variance is somewhere in between my original data. My s had 1 decimal place, so I'm going to jot down 1.48 when I do the calculations. Tell me if I'm wrong there. And I'm going to go to 2 decimal places, 5.46. But I'm not clearing out my calculator for that 1.48. I am taking my answer from this guy right here. I'm jotting down the 2 decimal places, but I'm square rooting that unrounded value. So I ended up with a 1.22. Don't square root 1.48. Square root the irrational answer that you got when you did the math. Same thing on the other side. I got a 5.46 because I had to write something down, right? But I'm going to take my answer and I'm going to square root that answer, not the 5.46, and I got a 2.34. I know it seems picky to you, but just smile and nod. So to me, variance is kind of the means to getting to the standard deviation. So I know that my standard deviation, if the sample of 20 cigarettes had a sample standard deviation of 1.6 milligrams, that means that my population, all the cigarettes in the world, have a standard deviation. I can feel 95% confident it's between 1.22 milligrams and 2.34 milligrams. So it's going to be surrounding that 1.6 that we had as our starting point. Hopefully that makes sense to everybody. I don't know how many examples we need to do here because it's a pretty simple plug and chug, use your formula. I do want to mention though, if we were going to do this problem, the lengths and minutes of a random selection of popular children's animated films are listed below. Assume the variable is normally distributed. Estimate the population variance and standard deviation in length of children's animated films with 99% confidence. So I'd have to do all the usual stuff, right? I'd need to know n so I can figure out my degree of freedom. I'd need to know s, and then I'd need to know my chi-square left and right. Chi-square left and right. Well, the n is easy. How many pieces of data do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm going to use degree of freedom 10. I need that when I find my chi-square value. Chi-square left and right, 99% confident means that alpha is equal to 1% or 0.01. And then alpha over 2 would be 0.005. So I'd look up my chi-square right with 0.005. I'd look up my chi-square left with 1 minus that, so 0.995. We got all that part, right? We can do that. S, where does S come from? We know whenever I give you a list of data, you are going to use your TI-84, figure out what your S is. Do not use your sigma. Use your S, your sample standard deviation. We only have 11 pieces of data here. We cannot apply this to the population with 100% confidence. So that's why we are doing this, to figure out what is the possible variance and standard deviation. So that is it for section 7.4b. That is it for chapter 7. So I hope you're feeling confident about writing confidence intervals and understanding what they mean. Thanks for sticking in there, and I will see you in the next chapter.